Hello students. In the last video, we discussed about the acidic strength of the alcohols and carboxylic acids. Just basics only we discussed. Now we will discuss in this video the acidic strength of the aliphatic carboxylic acids with examples. Right? Now the first example is CH3, CH2, CH, Cl, COOH. So this is the first one compound, carboxylic acid compound. Next, CH3, CH, Cl, CH2, COOH. Next, third one, CH2, Cl, CH2, CH2, COOH. Next, fourth one, CH3, CH2, CH2, COOH. So these are the carboxylic acid compounds. In these carboxylic acid compounds, now the first case with respect to the COOH group, one chlorine minus I group attached to the chlorine which is attached to alpha carbon atom with respect to carboxylic acid. Here in the second compound, here also the minus I group of chlorine attached to the beta position with respect to carboxylic acid. So it is alpha means it is beta position. Next, in the third case C, the minus I group of chlorine which is attached to the gamma position with respect to carboxylic acid. It is alpha position, it is beta, this one is gamma. Then next coming to this, now in this there is no electron withdrawing group is present. Totally these groups all are act as a plus I groups, electron releasing groups. So towards carboxylic acid, it releases the electrons. Now, in the above cases, these groups are withdraws electrons from the carboxylic acid. It is in the reverse manner only. Now, here also this one withdraws electrons like this. Now, here also this one withdraws electrons like this. Okay. In these given cases, these three cases are the minus I groups. This one only plus I. As for that given formula, we know that plus I group is decreases the acidic strength of carboxylic acid or alcohols. Next, minus I group, it is increases the acidic strength of carboxylic acids or the alcohols. Then, in these first three electron withdrawing groups only, these all are more acidic than the D. So, which one is the least in this? Now, the compound D is the least acidic. It is least acidic strength. Okay, one is we identified from the four. The next above three, A, B, C, here chlorine electron withdrawing group is very near. According to the inductive conditions, the distance effect is also affects in this. If distance increases, inductive effect decreases. If inductive effect decreases means, what about the acidic character? Decreases. Now, which one effectively withdraws electrons means the alpha position of the minus I group of chlorine, which is withdraws electrons from the carboxylic acid. Now, this group easily release the H plus ion. After that, the second compound, this one release the H plus ion easily than 3. Now, answer in this, A is more acidic than B, B is more acidic than C, C is more acidic than the D. So, this is the stability and acidic strength of the carboxylic acids. Okay, these are the, for the given compounds, we can identify the acidic strength of the carboxylic acids. This is the one kind of example. Next, one more. If CH3, CH2, COOH, it is a propanoic acid. Next, option B, CH2, double bond, CH, COOH. Next, third case, CH, triple bond C, CO, OH. This one is the third one. In these three cases, how to identify the acidic strength of the compounds? Just generally, if you identify in this, it is the sp3 hybridized carbons. The second compound, these are sp2 hybridized carbon. Third case, it is sp hybridized carbon, which are attached to the carboxylic acids. These are the carboxylic acid groups. So how to identify this in these cases? It depends on the percentage of S character. If a percentage of S character increases, percentage of S character increases, acidic strength also increases. Okay, which one is now more acidic character in this? Third option. C is greater than B, B is greater than A. So why in these three cases C only more acidic means the electronegativity character more here. Percentage of S character increases means which one increases? Electronegativity. Electronegativity means electron withdrawing nature. Electron withdrawing nature increases. So that's why here the third case is always more acidic than the second. Second is more than the first one. So this is the another kind of example with the reason. Okay, next one. Another example. A COOH bond COOH. It is called oxalic acid. This one is called oxalic acid. Next, the second one is COOH bond CH2 bond COOH. So this one is called malonic acid. The name of this one is called malonic acid. First one is oxalic acid. This one is oxalic acid. B is malonic acid. Next, third one. CH2 taken twice. COOH. So one more CH2 group increased in between them. Now this one is called succinic acid. Succinic acid. Okay. So these are the three compounds. In these three, which one is more acidic? So how to identify the acidic character in the following is given compounds. Now, generally we can identify this. Now, this group alone COOH is acts as a minus I. Here this group alone it is also acts as a minus I. Here also minus I. Just so generally identifying this. The minus I group is directly attached to the carboxylic acid in the first case. In the second case, the distance increased. The distance increased. If you identify one CH2 group is present here. If you identify the third case, two CH2 groups present. So if the distance increases, the inductive effect decreases. So minus I increases the acidic strength. If the distance increases, acidic strength is decreases. So order for the given compound is A is greater than B, B is greater than C. This is the acidic strength of given these compounds. Okay. Next, another example we will discuss in this. Next example is A in this CH2 COOH bond CH2 COOH. So again it is a succinic acid. Succinic acid. Now I'm writing the name also. Succinic acid. This one. Next, compound B, C double bond C H. Here also H, COOH, COOH. Here compared to this first one, here double bonded carbon atom only present. So this is the compound B. Next, compound C double bond COOH, COOH, H. Now, in the first case, it is a succinic acid. Already we know that. That is succinic acid. Then, coming to the second and third, B and C compounds. One is a maleic acid, another one is the fumaric acid. So, which one is maleic means the second one is maleic acid. Now, third case is fumaric acid. So, these are the compound names: maleic acid, fumaric acid, succinic acid. So, in these three cases, which one is more acidic? That one we have to identify in this. Now here the sp2 hybridized carbon atom between the two acid groups. Here one sp2 hybridized carbon atom is also attached to this. Now this complete group acts as a minus I group, electron withdrawing group only. Now 100% B and C is more acidic than the first one. It is confirmed. B and C more acidic than A compound. Why? Because it is sp3 hybridized, but these two are the sp2 hybridized carbon atoms. So in these two cases, the cis compound of this one is called maleic acid. The trans form of this one is called fumaric acid. Now, in between the B and C, in between the B and C, now this oxygen and these hydrogen, the partial negative charge of this oxygen attract the hydrogen. So, which bond here developed? It is hydrogen bond only developed in between the oxygen and hydrogen is cis compound, that is a maleic acid. But if you observe in the trans, there is no hydrogen bond is exist. So compared to this compound, this acidic nature is less. Here reason is due to the hydrogen bond formation. It is more acidic. So maleic acid is always more acidic than the fumaric acid. Now the total order for the given compound is B is greater than C, C is greater than A. This is the acidic strength order of the given these carboxylic acids. Then next, another example, H, or generally we know that formic acid H, CO, OH, another one is oxalic acid. Okay, one is, it is formic acid, this one oxalic acid, these two. Now, so how to identify the acidic strength in between the two compounds? So again, we will discuss in these two cases in the two categories. Okay, two categories only we will discuss. So what are the categories here? First, the first case and second cases. So generally we will discuss in the first case HCOOH and COOH bond COOH. It is a one case. Now coming to the second case, same condition only, HCOOH and another one is COOH bond COO minus. Okay. Now in these two cases, how to identify that acidic strength? Now coming to this one, hydrogen is neutral. Here also hydrogen is neutral. Neutral case. But in this case, two COOH groups are present. One COOH group alone, it acts as a minus I group. But in the second case, COO minus group acts as a plus I group. Plus I. Then in these given conditions, so which one is a more acidic? How to identify that? Okay, how to identify the acidic character? Now I am considering in this the COH group and here the Ka value of Ka value. This one considered here Ka. Now in this case it is considered Ka1. Again formic acid here Ka. This one is Ka2. Okay. So Ka and Ka1, which one is more acidic? How to identify? Electron withdrawing group is present. It always increases the acidic strength. Here neutral neither lose nor gains in this. Now always in the above case Ka1 is always more acidic than the Ka. This is the one case. Now coming to the below case, here electron releasing group plus I group only present here neutral. Compared to releasing group, here neutral is always a more acidic than this group. Now we can write this one is Ka is greater than Ka2. So finally, what is the conclusion here? So in the final conclusion, in these three given compounds, which one is always more acidic? So Ka1 is always more acidic than the Ka1 is always more acidic than Ka. Ka is more acidic than Ka2. This is the final answer. So in this given three conditions, we can say that the oxalic acid is always more acidic than the neutral compound of formic acid. So after that, releasing of one proton from the oxalic acid, that group alone acts as a plus I only. Now this one is the acidic nature of the given few compounds. So this is also very important. In this, we can identify by using the method. The next, generally, the relative strength of the acids and that conjugate basis only we will discuss now. So it is also very important. Relative strength only, relative. Okay. Next. So this relative strength is we have to memorize only and very important also. This one is relative strength acids and bases. Relative strength of acids and bases. So first I will give the acid strength only. You have to memorize this order. It is very important also based on these conditions. So mostly one question definitely they will ask in your NEET or JE conditions. First, which one is a more acidic? That inorganic relation only I will explaining first. Inorganic relation with the organic compounds also. HClO4. This one is called perchloric acid. Perchloric acid is always more acidic than the hydrogen iodide. Hydrogen iodide is always more than the hydrogen bromide. Then H2SO4, sulfuric acid. So sulfuric acid is stronger acid than the hydrogen chloride. And next after that, hydronium ion H3O plus, it easily release the H plus ions. Now this acidic character is also very higher than other acid, that is nitric acid. HNO3 is the nitric acid. Further, it is more than the HSO4 minus. After removal of H plus from the H2SO4, it is HSO4 minus is more acidic. Why? Because this one also has one hydrogen. The next, after this sulfate ion, bisulfate ion, next H3PO4, phosphoric acid. So this one also more acidic. Further, HF molecule is also acts as a acid. Next, the group is H2CO3, carbonic acid. So this carbonic acid is more acidic. Then after that, this carbonic acid H2S, hydrogen sulfide. Next, ammonium ion NH4 plus. Next condition is a HCN molecule, hydrogen cyanide. Then next, phenol, PHOH is the phenol. Next, water molecules. Next, after that, alcohol, C2H5OH. Next, hydrogen, only ammonia, and methylamine. If you add one methyl group to ammonia, CH3NH2 and CH4. So these are the acids acidic strength only. So if you know this order, you can easily solve the problems. HCl4, HHB4, H2SO4, HCl. And recently they asked like these questions: ethyl alcohol and hydrocarbons. Which one more acidic always? Ethyl alcohol is always more acidic than the CH4. So by using these conditions, here phenol and water, by using these, how to identify the conjugate base? Conjugate base, that is also very, very important. Now, next condition is conjugate bases. Conjugate bases. Now, same after removal of H plus from the acid. So how to write that one? From acid, if you remove H plus ion, it gives conjugate base. That is the condition. So suppose your strong acid given, always it gives weak conjugate base. Okay, strong acid always gives weak one. Or if you write weak acid gives strong conjugate base. So these are the conditions. Based on these conditions only, now we will write the conjugate bases according to these acids. HClO4, remove H plus ion, it gives ClO4 minus. Next, ClO4 minus, it is less than I minus. After that, Br minus. Next, HSO4 minus. Next one, Cl minus. After that, H2O. Next, NO3 minus. SO4 minus 2. H2PO4 minus. Next, F minus. HCO3 minus, bicarbonate ion. Next, SH minus. Next, ammonia, NH3 group. Next, Cn minus, PHO minus, OH minus, C2H5O minus. Next, H minus, NH2 minus, CH3NH minus, CH3 minus. So which one is a strong base? Which one of the following is a most basic? They will ask like these questions. Most basic. Most basic means the CH4 molecule. If you observe in this, CH4 molecule is a weak acid. Okay, this one is weak acid. So the weak acid always gives CH3 minus is strong conjugate base. Now, coming to this one, ClO4 minus, it is taken from the HClO4. This one is a strong acid. Strong acid always gives weak conjugate base. Okay, like this. If you know these orders, you can easily write and solve the problems. Okay, definitely one question they will ask in your final exam also. This is the very, very important relative strength of the acids and bases. So general condition only it is, but very, very important. Inorganic compounds related with organic compounds also. Then another kind of oxy acids also they will ask sometimes. That oxy acids relation, just one or two examples in this. Oxy acids. So that oxy acids signature increases with increase in electronegativity. Okay, which nature increases? Acidic nature increases with increase in electronegativity. This point also very, very important. Now, based on that, we will discuss few examples. Okay, first one, HOCl. First example, HOCl, HOBr, and HOI. So these are the three compounds. So OH is the common, but it is depends on the chlorine, bromine, and iodine. Those are only central atoms. Now, if electronegativity increases, acidic character increase. Now, chlorine, from chlorine, if you observe, it is a more electronegative, so that acidic nature is very high. Okay, HOCl acidic nature is very high in this case. The next, the same as like if you observe in another condition, HClO4, same like bromine here, HBrO4, HiO4, name of these compounds. Here above case it is called hypochlorous acid, hypobromous acid, hypoiodous acid. But in this case, it is perchloric acid, perbromic acid, periodic acid. So in these cases also it depends on the electronegativity character. So electronegativity character, which one is very high? So chlorine only again more acidic. Now this is a more acidic than the second one. Second one is more than the HiO4, third one. So this one is the acidic character depends on the electronegativity of the central atom only. Then if in the same case, if number of oxygen atoms decreases, so for oxy acids of same element, acidic nature increases with the increase in oxidation number. So next one it is depends on the increase in oxidation number. Oxidation number. So how it is, how we can identify that kind of compounds. So acidic strength increases in increase in the oxidation number of the compound. Now look here all of you. HClO4 minus perchloric acid. Now HClO3, chloric acid. Chloric acid, HClO3. Next one, HClO2, chlorous acid. This one is called chlorous. Next, HOCl or HClO. This one is called hypochlorous acid. Perchloric acid, chloric acid, chlorous acid. This one is hypochlorous acid. So in these two, it depends on the oxidation number. Oxidation number of this chlorine is +7. Now this one is +5. This one +3. Now chlorine here +1. Now if the oxidation number, which one is very high? HClO4. Now this compound acidic nature is very higher than the, it is a chloric acid. This is a chlorous acid. This one is hypochlorous acid. So by using this, we can easily identify the acidic nature. So another example here, one more, just another example. H2SO4 molecule, H2SO4 molecule. Next, HNO3 molecule, H2SO3 and HNO2, HNO2. In these given conditions, which one is a more acidic nature? Always H2SO4 is more acidic than the HNO3. Next, H2SO3. Least one is the HNO2. The oxidation state of sulfur in this, it is +6 oxidation state, and in this HNO3 molecule it is +5 oxidation state. Now in this case, +4 is the oxidation state of sulfur in H2SO3. Next, in HNO2 molecule it is +3. So if oxidation number increases, that acidic strength also increases. So this one more another example we can say easily by using the conditions only. Okay, so like this also few kind of examples they will ask in your exams. So sometimes another examples also they will ask. For example, HNO3 and HPO3 molecule given. HNO3, HPO3. So that means nitrogen, it is phosphorus, both the same family. The same family of the groups present in this. Then which one may here more acidic nature? HNO3 is always more acidic than the HPO3 molecule. So how to identify that? What is the oxidation state of both conditions? Oxidation state is same for the both nitrogen and phosphorus in this. So nitrogen oxidation state is +5, phosphorus also +5. So oxidation state for both conditions are same. Then it is depends on the size only. So depends on the size. So which one here more acidic now? HNO3 molecule is more acidic. Now phosphorus here compared to nitrogen, top to bottom size increases. So HNO3 molecule is always more acidic than the HPO3 molecule. So we can say this like this also. The size increases, the acidic strength also decreases. Okay. Okay, students. In the next video, we will discuss other important topics. Thank you.